Don't stop when you're tired, stop when you're done. We will start this video with this motivational quote, so continue watching this video till the end, as you should not stop when you're tired. You should stop when you complete watching this video, because in this video I have explained all the logarithmic concepts, formulas, and I have discussed various sums very easily. So I have made it very easy for you, so continue watching till the end. So watch and start solving. Logarithms are also called as logs. This is from Real Numbers Chapter, Maths Class 10. This is the part 2 video. You can go and watch the part 1 video before this video in order to get some basic knowledge about Chapter 1, Real Numbers. So let's begin. Consider there is an equation 10 power 5 is equals to 25. Now I want to find out the value of this y. As we know, here y is known as exponent, so I can say that this equation is in exponential form. Exponential form means when we have exponents, then it is called as exponential form. Exponent and power we have, so it is called as exponential form. Suppose I want to find out the value of y. Then we can find out the value of y as y is equals to log 25 to the base 10. There is this same equation. If I want to convert and if I want to find out the value of y, I can write it as y is equals to log 25. This 10 will become base to the base 10. This is called to the base 10 in logarithms. So this is the general form of logarithm. So this is called as exponential form, and this is called as logarithmic form. Okay, as you can see, in logarithmic form we have log, and in exponential form we have power. Now let us see different types of formulas of logs and different laws of logs. So as we can see here, the general form of log is represented as this. If you observe, this is a and this is x, we can assume, and this we can assume as capital N. So if we write a power x is equals to n, then if I am having this exponential form, then I can write x is equals to log n to the base a. This is my general formula of logarithm. That is, if a power x is equals to n, then the value of this x will be equal to log n to the base a. And in the question, if it asks x is equals to log n to the base a, then this form we have to use a power x is equals to n. We can use this both the ways. That is why I have put double arrow. That is, x is equals to log n to the base a form can be given in the question, and you have to make that equation in terms of a power x is equals to n. So remember both. First formula of log is if a power x is equals to n, then x is equals to log n to the base a. Now let us move to the second formula. Second formula is called as product rule. In previous classes, you all have learnt about exponents and powers. As we know that we have a power m into a power n is equals to a power m plus n. Similarly, this can be used to write logs also. That is, if I have log x into y is equals to this power, this is multiplication. Multiplication will become addition, log x plus log y. That is, if you observe here, a power m into a power n is equals to a power m plus n can be written as log x into y is equals to log x plus log y. That is, when log belongs to multiplication, then that is also equal to sum of logs. Okay, and where x and y are positive real numbers, and even this is base 10. I said this base in general is represented by base small a. So this base a here was 10. It can be anything. So we can also write log x into y to the base a is equals to log x to the base a plus log y to the base a. That is, this formula can be used with base a, or this formula can be used without base a. Now the next formula is quotient rule. By the name quotient, you can know that it is used for division. Here we had multiplication. So here we also know that in exponents we studied a power m by a power n is equal to a power m minus n. Similarly, this can be applied to logs, log x by y. So here in quotient rule we can see that when log x by y to the base a is equal to log x to the base a minus log y to the base a. That is, if log belongs to division, then it is also equal to difference of the logs. Division means difference, multiplication means addition. Remember like this. And the third one is power rule. In exponents, we saw that a power m whole n could have been written as a power mn. Similarly, in logarithms, we can write power rule log x power n to the base a. That is, here we are applying power. Log x power n to the base a is n log x to the base a. That is, here we can see that when we have logarithmic of power is equals to the logarithmic of power is equals to the exponent value into the log value of the number. This can also be written as log x power n is equals to n log x, or it can be written as log x power n to the base a is equals to n log x to the base a. Now we have some more formulas. The value of log n to the base n is always 1. That is, if we have two numbers which are equal, for example log 25 to the base 25, then that value will be equal to 1. Log n to the base n is always 1. Then we have one more formula, a power log n to the base a. This is looking a bit complex. A power log n to the base a. That is, in the power we have log n to the base a. That value will be just equal to n. So such a complex LHS is being resolved into just n. A power log n to the base a is n. So these are the various formulas of logs, and this product rule we applied log for two numbers. Log x into y to the base a is equals to log x to the base a plus log y to the base a. This can also be applied to three numbers. For example, we can also write log x into y into z to the base a is equals to log x to the base a plus log y to the base a plus log z to the base a. That is, if we have multiplication, then log belongs to all and it is addition. So multiplication means addition and division means subtraction, and power means that power will come beside log, and log n to the base n is 1 and a power log n to the base a is n. These were the various laws of logarithms. Right? Now let us see what are the values of logarithms from 1 to 10. We must remember the values of logarithms from 1 to 10 because sometimes it might be used to solve problems. In this video, we are also going to see various problems on logs. So continue watching because I am going to discuss the questions asked in the previous question papers in this video. Value of log 1 is always 0. Remember this value because this will be used in solving the problem. The value of log 2 is 0.3010. The value of log 3 is 0.4771. The value of log 4 is 0.602. The value of log 5 is 0.6989. The value of log 6 is 0.7781. The value of log 7 is 0.845. The value of log 8 is 0.903. The value of log 9 is 0.9542. The value of log 10 is 1. So remember, the values from log 1 to 10 are 0 to 1. That is, log 1 is always 0, log 10 is always 1. And if you observe, you can remember very easily. How we can remember this? In this, if you observe, log 1 is 0. It is in increasing manner. That is, log 2 is 0.3010. So after 0.3, 0.4 comes. So log 3 is 0.4771. Log 4 is 0.3 is over, 0.4 is over. Then log 4 and log 5 are 0.60 and 0.69. Then log 6 is 0.77. Log 7 is 0.8. Log 8 and log 9 are 0.9, 0.9. And log 10 is always 1. So like this, you can remember all the values of logs. Now let us move towards solving the questions. First, let us solve 1 mark question. Evaluate log 49 by 64. before solving any question, first learn all the formulas which we discussed just now. After learning all the formulas, then pause the video, learn all the formulas, write that in the book without seeing, and then come and watch these sums again, and again take a book and solve these questions while I explain and practice these questions. So if you observe here, log 49 by 64 is of the form log x by y. Observe here we don't have any base a, so no need to add base a. So log 49 by 64 is of the form of log x by y. Evaluate means find out. So we need to find out the value of this log 49 by 64. So log x by y we know is log x minus log y. So we'll expand this log x by y as log x minus log y. That is log, what is x? X is 49 minus y is 64. So log 49 minus log 64. Then if we observe 49 is a perfect square, it can be written as 7 square. 64 is also a perfect square, it can be written as 8 square. Because we know 7 sevens are 49, that is 7 square is 49, and 8 eights are 64, that is 8 square is 64. So I have written 49 as 7 square and I have written 64 as 8 square. Now again this is of the form of log x power n. We know log x power n is n log x. So this is LHS is given to us. We need to write this LHS in terms of RHS. So if you compare this, log is as it is, x is 7, n is 2. So here n is 2 and x is log is there, n log x. X here is 7 minus, similarly this is also of the form of log x power n. Log x power n is n log x. So here if we observe and compare this with this formula, x is 8 and n is 2. 2 log 8. Now observe what we can do in this. 2 is present in the first term as well as 2 is present in the second term. So as 2 is present in both the terms, we can take 2 common. So I am taking 2 common. If I take 2 common, I am left with 1 here. So log 1 into log 7 is log 7 minus, again if I take 2 common here, 1 is left, 1 into log 8 is log 8. Further I cannot expand this more, so this is my answer. If you want, you can write the value of log 7 and find out the value if it in case in exam, if it asks in multiple choice questions and if it gives a number, then you can do more steps. Like we know 2 into log 7 value is 0.845 minus log 8 value is 0.903. So 2 into, we can subtract these both, 0.903 minus 0.845, 8, 10, 9, 13. 13 minus 5 is 8, 9 minus 4 is 3. So we got 0.038 as the answer. So again, as we have bracket here, we have to multiply this. So 0.038 into 2 is 2 8s are 16, 2 3s are 6, 6 plus 1 is 7, 2 0s are 0, 2 0s are 0. So I am getting 0.076. No need to find out the value if it asks in 1 mark. Okay, if it asks in 2 marks, you can substitute the value of log 7 and you can substitute the value of log 8, as you can remember these values of logs and you can substitute and find out the answer. Otherwise, just stop here, 2 into log 7 minus log 8, because we cannot subtract log 7 and log 8, because here 7 is there and here 8 is there. Both are different. I hope you are able to understand. Now let us move to the second question, which is also 1 mark question. If you observe this question, it is log 343 to the base 7. So here also log 343 to the base 7. Now 343, remember the perfect cubes. 7 cube is 343. If you don't know the perfect cubes, you can go check the playlist of maths basics explained like never before on my channel, and in that you can watch perfect cubes and learn it. So 343 is 7 cube. So 7 cube to the base 7. Now observe this. This is the form of log x power n to the base a. So log x power n to the base a is n log x to the base a. So I will write, observe here what is, compare this with this log x power n to the base a. For your better understanding, I'll write one time what is x, what is n and what is a. x here is 7, n here is 3, and a is also 7. So it is n log x to the base a, right? So n is 3 log as it is x is 7 to the base a is 7. Now observe 3 into, again this is one more formula, log 7 to the base 7 is in the form of log n to the base n. So we know that log n to the base n value is 1. So instead of log 7 to the base 7, I'll substitute its value 1. So 3 ones are 3. So this is the value. This was asked in the previous batch exam. Okay. So here if you observe here, find the value of log 343 to the base 7. The value we got is 3. This is how you have to solve these sums. Now let us move to the next question. So here also it is a similar type of question where it is asking us to find out the value of log 243 to the base root 3. So value means again we will get a number, and how to solve this? First write down log 243 to the base root 3. Now we should expand this 243, that is we should open this 243. How to open this 243? By prime factorization of 243. So if you find out the prime factorization of 243, 243 goes in 3 table. 3 8s are 24, 3 1s are 3, 3 2s are 6, 8 minus 6 is 2 1, 3 7s are 21, 3 9s are 27, 3 3s are 9, 3 1s are 3. So here we got 3 is 1, 2, 3, 4, 5. 5 times 3 is 243. So we can write this as log 3 power 5 to the base root 3. But if you observe, we are having in terms of root 3. So we should write this also in terms of root 3. If 3 is in terms of 5, then here I can apply this 3 as root 3 into root 3, because I know 3 is equals to root 3 into root 3. So this 3 can be written as root 3 into root 3. Similarly, this 3 can be written as root 3 into root 3. Similarly, the remaining 3 can also be written as root 3 into root 3. So that is, if 1 is 3, then we are having 2 times as root 3. So 3 power 5 can be written as root 3 power 10. I hope you have understood why. Because 3 is root 3 into root 3. So as we are having 5, we should double it. 5 2s are 10. So 10 times you are having root 3 is nothing but 243. See, if you write here as root 3 into root 3, root 3 into root 3, root 3 into root 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll get 10 times. That is, just double it. 3 is equal to root 3 into root 3. So just double it. You will get root 3 power 10. So we can write log root 3 power 10 to the base root 3. This is in the form of log x power n to the base a. Log x power n to the base a is n log x to the base a. So n here is, compare this, n here is 10 log as it is, x here is root 3 and a here is root 3. Now observe again it is log root 3 to the base root 3. We know log root 3 to the base root 3 is in the form of log n to the base n, and we know because both are same na, n root 3, so that value is 1. So 10 into 1 is 10. So this is how you find out the value of log 243 to the base root 3 is 10. Now let us move to the next question where we have write log 25 to the base 5 is equals to 2 in an exponential form. As we saw in the first video that we have two forms, logarithmic form and exponential form. So this equation is in terms of logarithmic form, that is it is in the form of log n to the base a is equals to x. We have to make it in the exponential form, that is we have to make it in the form of a power x is equals to n. So let me compare this log 25 to the base 2 with a power x is equals to n. So if we see here, it is log 25 to the base 5. So I have n is 25 and a is 5. Exponential form as a is 5 power x. Here x is 2 if you observe. This is given log 25 to the base 5 is equals to 2. Now we are using this formula. If log n to the base a is equals to x, then a power x is equals to n. We are writing this exponential form. So we got by comparing this, n is 25, a is 5 and x is 2. So a power x means it is nothing but a is 5 and x is 2 is equals to n, that is 25. We know phi square is equals to 25, so our answer is correct. This is the exponential form of log 25 to the base phi is equals to 2. These all are one mark questions. Now let us move to the next question. We have to find out the value of log 5 to the base 10 plus log 20 to the base 10. So here and options are given to us. Whatever we will get, we will take that answer. Now observe this. This is in the form of log x to the base a plus log y to the base a. So we know that first we'll write given log 5 to the base 10 plus log 20 to the base 10. This is given. Now this is in the form of log x to the base a plus log y to the base a is equals to log x into y to the base a. So here if I compare this, x is 5, y is 20. So log 5 into 20. Now I know that I can further expand 20 as 2 into 5 because 2 2s are 4, 4 5s are 20. Now again I can write this as log 5 to the base 10 plus log 2 to the base 10 plus log 2 to the base 10 plus log 5 to the base 10, because again it is reverse applied. These 4 are given here. Or we can say log w x y z is equals to log w to the base a plus log x to the base a plus log y to the base a plus log z to the base a. That is 4 terms are here, so we are applying and we are writing plus. Now if we observe here, log 5 to the base 10 is here and log 5 to the base 10 is here only also. So the coefficient here is 1 and here also the coefficient is 1. So log 5 to the base 10 plus log 5 to the base 10 is 2 log 5 to the base 10, and log 2 to the base 10 plus log 2 to the base 10 is 2 log 2 to the base 10. Now again we observe that 2 is present here and 2 is present in this term also. So we will take 2 common. Now here log 5 to the base 10 is left and here log 2 to the base 10 is left. Now we know the values of logarithmics. Those values of log 5 and log 2 can be applied as log 5 to the base 10 value will also be same as log 5. So 2 into, we know the value of log 5 is 0.69. Memorize that formula and memorize the value of these logs values. Log 2 to the base 10 is 0.301. Now we will add 0.69 plus 0.301. We will get 0.991. Now 0.991 into 2. 2 1s are 2, 2 9s are 18, 2 9s are 18, 18 plus 1 is 19, 2 zeros are 0, 0 plus 1 is 1. So you are getting 1.982. 1.982 is very nearer to 2 value because 1.982 means it is more than 1.5. So that value is approximately equal to 2. So my answer is option B, that is 2. So it's very easy. Hope you have understood this. Now let us move to the next question, which is if x is equals to log 5 to the base 3 and y is equals to log 7 to the base 3, then we have to express log 35 to the base 3 in terms of x and y. This x value is given to us and y value is given to us. We have to write this log 35 to the base 3 in terms of, again, answer should be in terms of x and y. So here if we observe, given log 35 to the base 3 is given and also x value is given as log 5 to the base 3 and y value is given as log 7 to the base 3. Now how can we write this log 35 to the base 3? We can do one thing, that is we can expand this 35 by prime factorization. We know 5 7s are 35 and 7 1s are 7. So log 35 can be written as 5 into 7 to the base 3. Now this is again of the form of log x into y to the base a. We know log x into y to the base a is equals to log x to the base a plus log y to the base a. So we can write this as where x is 5 and y is 7. Log 5 to the base 3 plus log 7 to the base 3. Since here we have base 3 and base 3, we cannot find out the value of. Stop here since it is 1 mark question. Next question is also a similar type, that is x and y values are given and you have to express that question in terms of x and y. So here if you observe, it is asking us to find out the value of log 6750 and it is given x is equals to log 3 to the base 2 and y is equals to log 5 to the base 2. So same thing I'll write here, given to find log 6750 to the base 2 and it is also given that x is equals to log 3 to the base 2 and y is equals to log 5 to the base 2. So what we can do here, we have to express in terms of these x and y. This we have to find out. Since this we have to find out, we can expand this 6750 by prime factorization. So since we have 0 here, we'll do it with 5 table. 5 ones are 5, 6 minus 5 is 1, 7, 5 3s are 15, 2, 5, 5 5s are 25, 5 zeros are 0. Now again, 5 2s are 10, 3, 5, 5 7s are 35, 5 zeros are 0. Now since there is 27, we'll try with 3. 3 9s are 27, 3 zeros are 0. 3 3s are 9, 3 zeros are 0. 3 1s are 3, 3 zeros are 0. Then 2 5s are 10, 5 1s are 5. So we can write this 6750 as, how many 5s we have here if we observe? 1, 2, 3. 3 5s we have means we can write it as 5 cubes. And how many 3s we have? 1, 2, 3. 3 3s we have. So into log 3 cube into log 2. Now you might be wondering, why did I write into? Into means all these are into only. Now 5 into 5 into 3 into 3 into 3 into 2 into 5. So that is why I have written into only. Log, that is 5 3 times I have written 5 cube into 3 times I have written log 3 cube into, again 2 is only 1 time, so log 2. Now observe this to the base 2 we have. This is the form of log, this whole 5 cube can be assumed as x, 3 cube can be assumed as y, and 2 can be assumed as x. There is log x into y into z can be written as, here log should not come, log 5 cube into 3 cube into 2 can be written as log x into y into z can be written as log x plus log y plus log z. So x is 5 cube here means log 5 cube plus y is 3 cube here means log 3 cube plus z is 2 here means log 2. Now observe this, this is again of the form of log, so I'll write the formula being used here, log x y z to the base a is equals to log x to the base a plus log y to the base a plus log z to the base a. I'm sorry for writing very roughly, but you know the formula, so write it. Now this is again in the form of log x power n, log x power n, log x. So log x power n formula is n log x. So RHS form, LHS form is given to us, we need to write it in the form of RHS. So x is 5, compare, n is 3. So n log x, n here is 3 log 5 plus again here, compare this with log x power n, x is 3, n is 3. So 3 log 3, then we also have log 2 is equals to, what we can do here, log 5 value, we forgot to write base 2 here, base 2, base 2, base 2, base 2. Now here we know the value of log 5 to the base 2 is y. So 3 into, instead of log 5 to the base 2 I will write y plus 3 as it is, instead of log 3 to the base 2 I will write x plus, so we know log 2 to the base 2 is in the form of log n to the base n. We know log n to the base n is 1. So instead of log 2 to the base 2, I'll write 1. So what is my answer? 3y plus 3x plus 1. In the question, it said us that the answer should be of the form of x and y is given to us. Now let us move to the next question. The next question, it is a 2-mark question. It is given that if x square plus y square is equals to 25xy, then we have to show that 2 log x plus y is equals to 2 log 3 plus log x plus log y. So this is the prove that condition, and this condition is given to us, x square plus y square is equals to 25. Given x square plus y square is equals to 25xy. Now observe how to solve this. This is a bit different question, right? Here it is 2 log x plus y. There is, here we have 2 log x plus y means we have to add 2xy on both sides. Why? Because here we have log x, here we have log y. So if we add 2xy on both sides, this will have the form of x square plus y square plus 2xy. We know x square plus y square plus 2xy is same as a square plus b square plus 2ab. Now we know a square plus b square plus 2ab is a plus b whole square. So what we will do is we will add 2xy on both sides in the given condition. That is, this condition is given now. So we will write adding 2xy on both sides. So x square, and we will add 2xy. X square plus y square plus 2xy is equals to 25xy plus 2xy. Now this is the form of a square plus b square plus 2ab. We know a square plus b square plus 2ab is a plus b whole square. A here is x and b here is y. So x plus y whole square is equals to 25 plus 2. Both are xy. So we can add the coefficients. 25 plus 2 is 27xy. Now what we can do? Observe, here we have only x plus y whole square is equals to 27xy. But if you observe in this condition, we can clearly see that the question is in terms of log. As the question is in terms of log, we need to write log on both sides. So what we will do is add log on both sides. Since in the show that condition, we have to write it in terms of log. So now this will become log x plus y whole square is equals to log 27xy. Now observe, this is again of the form of log, this whole assume as x plus y assume as x, because this is log x power n. So log x power n is n log x. Log x power n is n log x. So n here is 2 and x whole is x plus y. So n log x. Now observe, in the RHS, here we have 27 and in the given condition we have 3xy. Here also we have 27, x and y is there, but 27 is there. So what we can do? First, it is in the form of 27 can be assumed as one term, that is x can be assumed as y, and y can be assumed as z. This is of the form of log x, y, z. We know log x, y, z is log x plus log y plus log z. So we can write this 27 as log 27 plus log x plus log y. Why? Because this is the formula. Log x, y, z is equals to log x plus log y plus log z. This LHS we got. Did you observe? 2 log x plus y we had to show. We got the LHS. We just have to concentrate on the RHS and bring it in this term. So 2 log x plus y will write as it is because we got the LHS. Now log 27. How can you write 27? We know 27 is a perfect cube. That is 3 cube is 27. So instead of 27, I'll write 3 cube plus log x plus log y. Now observe this. This is in the form of log x power n. So log x power n is n log x. Right? So 2 into log x plus y is equals to 3 log 3 plus log x plus log y. So it's very easy, right? Did you understand? We got the RHS condition 2 log 3 plus log x plus log y. In the question it has done a mistake. This should be 3 log 3. So it is in the form of 3 log 3 plus log x plus log y. Okay, some printing mistakes might be there in the question. So here we should have 3. So this is the answer. See, LHS compared, RHS compared. We got the answer. I hope you have understood what we have done. Always remember, in these type of questions, the given condition, from the given condition, you have to add something. So I can add 2xy here. Why? Because it is in the form of a square plus b square. So I am adding 2xy on both sides. So if I add 2xy on both sides, it will become a plus b whole square. Now observe this again and compare the show that condition. In the show that condition we have in terms of logs. So we will add log on both sides. Then we apply formulas and finally we get the answer. Let us move to the next question. We have to show that log 162 by 343 plus 2 log 7 by 9 minus log 1 by 7 is equals to log 2. In this question, observe, this is of the form of log x by y. Again, log x by y, log x by y. So which formula we can use? Log x by y is log x minus log y. X is 162, y is 343. So we can write this as log 162 minus log 343 plus 2 into, now this 2 belongs to 7 as well as 9. So we'll open the bracket, log 7 minus log 9 minus log 1. Now this minus again belongs to 1 as well as 7. So I'll open the bracket here. 1, we should be very careful and open the bracket if minus is there or if any number is there before the whole term, plus minus log 7. Here we'll consider LHS, take LHS, because we have to prove this LHS is equals to RHS, log 2. Our final answer should be log 2. So I am considering LHS. Okay, I'll get the answer as log 2. So we know that, again, do the prime factorization on 162 and write it in terms of 2. 162 we can write as 2 8s are 16, 2 1s are 2. Now this will go in 3, 3 2s are 6, 2 1, 3 7s are 21, 3 9s are 27, 3 3s are 9, 3 1s are 3. So we can see here that it is 4 times is 3 power 4. So 162 I can write it as 2 into 3 power 4 minus log, again 343 is the perfect cube, 7 cube is 343, learn the perfect cubes, plus here if I observe, here I have only log 7 and here I have only log 9. So what I will do is I will apply 2 and I will open the bracket, that is 2 into 2 belongs to log 7 as well as 2 belongs to log 9. So 2 into log 7 is 2 log 7 minus 2 into log 9 is 2 log 9. Now again I will open the bracket, minus belongs to both. So minus log 1 and here I have minus into minus is plus. So plus log 7. Now what we can do, observe, we know that log 2 into 3 power 4 is in the form of log x into y. What is log x into y? This y is 3 power 4 and x is 2. So log x into y is log x plus log y. So I can write log 2 into 3 power 4 as log 2 plus log 3 power 4 minus, this is in the form of log x power n. So I'll write here log x power n is n log x, so 3 log 7 plus, here I have minus 3 log 7 plus 2 log 7 minus 2 log 9 minus log 1 plus log 7. Now again this is the form of log x power n. Log x power n is n log x. So log 2 plus 4 log 3 minus 3 log 7 plus 2 log 7 minus 4 log 3. Squared is 9. Okay. Plus 2 log 7 minus 2 log 9 again can be expanded as 3 squared. 3 squared minus log 1 plus log 7. So that is nothing but log 2 plus 4 log 3 minus 3 log 7. 2 log 7 minus. This is again of the form of log x power n. Log x power n is n log x. So 2 into 2 log 3, because this 2 will come here, plus minus log 1 plus log 7. So that is nothing but log 2 plus 4 log 3 minus 3 log 7 minus 3 log 7 plus 2 log 7 minus 2 2s are 4 log 3 minus log 1 plus log 7. So here I have plus 4 log 3 and here I have minus 4 log 3, so both will get cancelled. And also 2 plus 1, here I have 2 log 7 and here I have 1 log 7. So 2 plus 1 will give me 3. So 3 log 7 and minus 3 log 7 will get cancelled here. I am left with log 2 minus log 1. I know the value of log 1 is 0. Remember all the log values. I am saying again and again, please remember all the log values. I said in the beginning of the video. Log 2 minus log 1 is 0. So log 2 minus 0 is log 2. So we got the RHS. Hope you have understood this video. So we have proved LHS is equals to RHS. So in such type of questions, always take the LHS and solve. This is a 4 marks question. Log 2 is RHS. This is a 4 marks question. And this is given. Take LHS. LHS is 1 by 2 log 25 plus log 3 minus 1 by 3 log 27. This is LHS. Now this can be written as 1 by 2 as it is. We have to make it equal to log x and then we have to find out the value of x. That is the question. So I can expand 25 as 5 squared plus log 3 minus 1 by 3. Again I can expand 27 as 3 cube. So now this is in the form of log x power n. We know log x power n is n log x. So 1 by 2 into this 2 will come here into log 5 plus log 3 minus 1 by 3 into, again this is the form of log x power n. Log x power n is n log x. So 2 1s are 2, 2 1s are 2, here will get cancelled, and here also 3 1s are 3, 3 1s are 3. So here I am left with log 5 plus log 3 minus log 3. Now log 3 and minus log 3 will get cancelled. Now that is equals to log 5. Now this was given as, this whole value was given as equal to log x. So what will write? Given that is equals to log x. We know that, right? So compare this. When log is present on both sides, then whatever is attached to them, that is equal. So log is here means the value of x is equals to 5. Hope you have understood this question. See, whenever log a number is attached to log, that will be the value, that is x is 5 here. The next question is, find x if 2 log 5 plus 1 by 4 log 81 minus log 3 is equals to log x. This is also the same type of question. If you observe, you have to find out the value of x, and LHS and RHS is given to us. So again what we will do is, we'll write whatever is given, that is 2 log 5 plus 1 by 4 as it is. 81 we know, from that time we were calculating, it is 3 power 4 minus log 3 is equals to log x. This is given to us. So implies 2 log 5 plus 1 by 4 into, again log x power n is in the form of n log x. Log x power n is n log x. So I'll write this as 4 log 3 minus log 3 is equals to log x. Now here 2 log 5 plus 4 1s are 4, 4 1s are 4, I am left with log 3 minus log 3 is equals to log x. Now here plus log 3 and minus log 3 will get cancelled. So I got 2 log 5 is equals to log x. But here I am given in terms of log x. That is, here I have to write log some number. So what I can do is, if I compare this with the formula n log x, this is in the form of n log x. We know n log x is log x power n. So write it in terms of log x power n, convert it. So log x here is 5 and n here is 2. So log 5 square is equals to log x. Now here 5 square is 25. So log 25 is equals to log x. Now we know that whenever we have log is present on both sides, then whatever is attached is equal. So x is equals to 25 we got here. So both are same type of questions. Hope you have understood how to do it. Right, the basic thing is you have to expand everything and you have to remember the formulas, then it will be very easy. Just have few more questions remaining. This question is also same as the previous two questions which we did. Here it is given that log 75 by 16 minus 2 log 5 by 9 plus log 32 by 343 value is given as log p. I have to find out the value of p. Instead of x, here it gives p. So again what I will write, log, I can write this log 75 by 16 is in the form of log x by y. I know log x by y is nothing but log x minus log y. So I will write this as log 75 minus log 16. Then minus 2 is there. It means minus belongs to and 2 belongs to the whole fraction. So log 5 again is in the form of log x by y. Log 5 minus log 9 plus log, again this is the form of log x by y. That is log 32 minus log 243. Now I can expand 75 as 5 1s are 5, 2 5, 5 5s are 25, 5 3s are 15, 3 1s are 3. That is 5 square into 3. I can write 75 as 5 square into 3 minus 16 can be written as 2 power 4 because 2 power 4 is 16 minus, open the bracket, 2 into log 5 is minus 2 log 5 and minus 2 into minus log 9 is plus 2 log 9 plus again 32 can be expanded as 2 1s are 2, 1, 2, 2 6s are 12, 2 8s are 16, 2 4s are 2 2s are 2 1s are. So I can write 32 as 2 power 5. So 2 power 5 minus, we know 343 is 3 power 5 We already did from that much time. 243 we expanded, right? Similarly you have to expand like this only. 243, it will go in 381s, and similarly you have to continue doing. Okay, I'm not doing it since we are doing from that time. Now observe, this is the form of log x into y. This whole x is y phi square. So log x into y is log x plus log y. We know this is the formula that we have to apply here, and also if we observe, this is the form of log x power n. That formula also will apply. Log x power n is n log x. So log phi square plus log 3, I am applying the formula, minus log 2 power 4 means 4 log 2, because it is a form of n log x. 4 log 2 minus 2 log phi plus 2 log 9 plus, again it is the form of log x power n. So phi log 2 minus phi log 3. And now we know, again it is the form of log x power n is n log x. So we'll write 2 log phi plus log 3 minus 4 log 2 minus 2 log phi plus 2, instead of 9 I'll write 3 square, because I am having all are 3, log 3 I am having here. So 3 square plus phi log 2 minus phi log 3. So here if I observe, 2 log phi and minus 2 log phi will get cancelled, and I am left with log 3 minus 4 log 2 plus, again this is the form of 2 as it is. I'll have 2 as it is. This is the form of log x power n. Log x power n is n log x plus phi log 2 minus phi log 3. So that will be equal to log 3 minus 4 log 2 plus 2 2s are 4 log 3 plus phi log 2 minus phi log 3. Now if you observe here I have log 3 minus phi log 3 and plus 4 log 3. Minus phi log 3 plus log 3 will give me minus 4 log 3. So minus 4 log 3, and already I have plus 4 log 3 here. Then apart from that I have minus 4 log 2 and plus 5 log 2. Minus 4 log 2 and plus 5 log 2. Minus, both are log 2. Log 2 means I can either add the coefficients or subtract the equations. I have minus and plus means I have to subtract. 5 minus 4 is 1. So plus log 2. Now both will get cancelled here. Minus 4 log 3 and plus 4 log 3 will get cancelled here. Now it said that if this whole condition is equals to log p, so I have to equate this log 2 with log p. So if I equate this log 2 with log p, I got to know that the value of p is 2. In the 13th question we have, write 2 log 3 plus 3 log 5 plus 5 log 2 as a single logarithm. This is the 2 marks question. In this question you can see that this whole we have to write as a single logarithm, means we should get log and some number. There is only one value we should get by simplifying this. So let us take this 2 log 3 plus 3 log 5 plus 5 log 2. If you observe, this is of the form of n log x. We know that n log x is log x power n. So this will become log x power n, means log x here is 3, power n is 2, plus again n log x is log x power n. So log x is here is 5, power n is 3, plus log 2. Now again log 3 square is 9, plus log 5 cube is 125. Remember the perfect cubes, it is there on my channel, plus log 2. Now if we observe, this is of the form of log x plus log y plus log z. We know that log x plus log y plus log z is equal to log x y z. So that is nothing but log 9 into 125 into 1, 5 log 2 in the question. So here we have log 2 power 5. Log 2 power 5 means 32. So here also I'll have 32. So log 9 into 125 into 32. Now we can expand this as multiply 125 into 9. 9 5s are 45, 9 2s are 18, 18 plus 4 is 22. 220, 9 5s are 45, 9 2s are 18, 18 plus 4 is 22. 9 1s are 9, 9 plus 2 is 10, 11. We are getting 1125. 2 5s are 10, 2 2s are 4, 4 plus 1 is 5, 2 1s are 2, 2 1s are 2, 3 5s are 15, 3 2s are 6, plus 1 is 7, 3 1s are 3, 3 1s are 3. So we are having 0, 5 plus 5 is 10. 2 plus 1 is 3, so 7 plus 3 is 10, 3 plus 2 is 5, 5 plus 1 is 6, so we got 36,000. So log 36,000, that is I am getting a single logarithm now if I see. Why single logarithm? Because this whole big expression 2 log 3 plus 3 log 5 plus 5 log 2 I have reduced and simplified as log 36,000. There is only one value. So I have satisfied the question, that is I have expanded it as single logarithm. I got the answer log 36,000. This is my single logarithm. Now let us move to the next question. Solve 3 power x is equals to 5 power x minus 2. So observe here 3 power x and 5 power x minus 2. This is given. If we observe, this is the form of exponential form a power x. So we need to convert this exponential form a power x into logarithmic form. Write this as a power x. A power x is n log x. So 3 power x can be written as x log 3 to the base 10. Okay, we will apply base 10 here. Since we have exponents, whenever we convert exponents into logarithmic, it is good if we convert it with bases 10. So I am writing a power x is of the form of n. A power x is equals to n. Then it is of n log x. So n log x to the base a is equals to, again, n is x minus 2 here, n log x 5. So implies x log 3 to the base 10. Now open this log 5 in the bracket. Log 5 into x is x log 5 to the base 10. Then here I have minus 2 into log 5 to the base 10 is minus 2 log 5 to the base 10. Now we'll bring x terms one side. That is, keep this, since this 5 is bigger than 3, I'll keep this x log 5 to the base 10 on the LHS, and I'll take this x log 3 to the base 10 on RHS. So it becomes minus x log 3 to the base 10. And since I have taken this on this side, this minus 2 log 5 to the base 10 I'll send on that side. So it becomes plus 2 log 5 to the base 10. Now here I am asked to solve. Solve means, always remember, find out the value of x. Solve means to find the value of x. So here also I have to find out the value of x. So since I have to find out the value of x here, I'll take x common from these both. So what is left if I take x common from both the terms? Log 5 to the base 10 minus log 3 to the base 10 is equals to 2 log 5 to the base 10. Now that implies we want the value of x, right? So x is equals to, what is there here? 2 log 5 to the base 10. Now here this is x into. So into term, if it goes that side, becomes divided by. So it becomes divided by log 5 to the base 10 minus log 3 to the base 10. So this is my answer. Since the value of log 5 to the base 10 is not mentioned in the question and the value of log 3 to the base 10 is not mentioned in the question, we will stop here, and this is the value of x. Now let us solve the last question of this video. In this question, if you observe, determine the value of 2 power 2 plus log 3 to the base 2. Now this question is a bit different, so observe carefully. Here it is of the form of a power m plus n. We know that a power m plus n is, so 2 power 2 plus log 3 to the base 2 can be compared with a power m plus n. A power m plus n is a power m into a power n. So 2 square plus log 3 to the base 2 can be written as 2 square into 2 power log 3 to the base 2. A power m into a power n. Now 2 square we know is 4, and if you observe this, 2 log 3 to the base 2. It is of the formula which we discussed. It is in the form of a log n to the base a. We know that a log n to the base a is equals to n. So here 2 log 3 to the base 10, if you compare, n is 3 here. So 4 into 3, because a log n to the base a is n, so n here is 3. So 4 into 3 is 12. So 12 is my answer. Hope you have understood all these sums. If you have understood all these sums, please like the video. Comment if you have any doubts in this video, and also share this video with your friends, and also subscribe to this channel if you have understood all these videos. Thank you very much for watching. Stay blessed.